Dear students, now here we have the problem 4 from the topic linear differential equations with variable coefficients. Already we have seen type 1, which was a second order linear differential equation with variable coefficient, and that was a homogeneous equation. Now here we are seeing type 2, which is also a homogeneous equation, but it is a higher order linear differential equations with variable coefficients, because the order of the equation is 3 here. So we shall solve this problem now. The question is, one solution of this equation given for x greater than 0 is phi 1 of x equal to x. Find a basis for the solution for x greater than 0. Already we have seen the definition of basis, where we saw that for the equation L of phi equal to 0. Okay, so this is a linear differential equation with variable coefficients, and it is a homogeneous homogeneous equation, because the right hand side is 0. For this equation we will have solutions phi 1, phi 2, and if it is higher order it will have solutions till phi n, and these solutions form a linear space, and if these are linearly independent to one another, then they form a basis for this equation. Okay, for the solution of this equation. So that is the definition of basis. So here they have asked us to find a basis for this solution, which means that we have to find the remaining solutions. Now this equation is a third order equation, so it will have three solutions. One of the solution is already given, so we have to find the two more solutions of this equation. So that is the question. So now it is given that this equation has a solution phi 1 of x is equal to x. Now we have to find the other two solutions phi 2 and phi 3, for which we will generally first of all write the solution phi of x to be equal to u phi 1. So that is equal to u multiplied with x. So generally we are taking it as 5. So after evaluating that 5, let us find phi 2 and phi 3 from that separately. Now phi of x is equal to ux. So from this phi dash of x we have to find, which will be equal to, now we have to use uv method here. So u multiplied with 1 plus x multiplied with u dash. So it will be u plus x u dash. And then we have to find phi double dash of x. So phi double dash of x will be equal to, the differentiation of u is u dash, plus the differentiation of x u dash is x u double dash, plus for x it is 1 and u dash. And so this is 2 u dash plus x u double dash. Next we have to find phi 3 dash of x, because in the question we have the third derivative also. So that will be equal to the differentiation of this, which is 2u double dash plus x u triple dash plus u double dash multiplied with 1. So that is equal to, now if you see we can add these two and we can write this as 3u double dash plus x u triple dash. So this is phi 3 triple dash of x. Now we shall substitute this phi of x, phi dash of x, phi double dash of x and phi triple dash of x in our given equation. So in our given equation, first of all, when we substitute phi in place of y, we will be getting x cube phi triple dash of x minus 3x squared phi double dash of x. So actually in the question this is y double dash. I didn't write that. So y double dash plus 6x y dash minus 6y. So when we replace it by phi, so double dash of x plus 6x phi dash of x minus 6 phi of x equal to 0. Now we shall substitute each of this separately into this equation. So after substituting phi triple dash of x, phi double dash of x, phi dash of x and phi of x in this equation, we obtain this. Now we shall multiply these terms inside and we can simplify it. So when we multiply, we get this. So when x cube is multiplied with this, we get x power 4 u triple dash plus 3x cube y double dash, and this when multiplied with this, negative 3x cube y double dash minus 6x squared u dash plus 6x multiplied with this. So 6x squared u dash plus 6ux minus 6ux equal to 0. Now if you see in this, we can cancel these two terms, and also these two terms, and so the only left out will be x power 4 u triple dash equal to 0. So we write this equation. Now this equation, on dividing by x power 4 on both the sides, we get u triple dash is equal to 0. And then we can write the auxiliary equation of this equation, that is the characteristic equation polynomial, which is r cube equal to 0. So if this is the characteristic polynomial, what about the roots of this equation? The roots of this equation will be, the first root will be e power 0x, comma, it's a 0 is of multiplicity 3, because r cube is 0, which means r equal to 0 comma 0 comma 0, and it's a repeated root. The roots are repeated. So if it is a repeated root, then what we have to do, the solution will be e power 0x. The next solution has to be multiplied with x. So x power 0x, and the next solution will be x squared e power 0x. And what is e power 0? It is 1. And x e power 0. So e power 0 is 1. So it is x and x squared. These three are the solution of u triple dash. That is the value of u. So u takes three different values. So let us see in each case what will be the value of phi. So these are the value of u. So when u is equal to 1, what will be phi? Phi is equals to ux. Okay, and so that is equal to, actually, so u, when you substitute 1 here, it will be x. So one of the solution phi 1 is equals to x, which is already given in the question. So when you substitute u equal to 1, you are obtaining a solution phi 1 equal to x, which is already there in the question. So now when x is equal to, u is equal to x. What about phi? We know that phi is ux. So when you substitute u as x here, it becomes x squared. And so the solution phi 2 is equal to x squared. So this is the second solution. And then when u is equal to, the third is x squared. X squared, what do we obtain phi to be? Phi is ux. When you substitute u as x squared, you get ux cube. So therefore the third solution phi 3 is equal to x cube. So we have obtained the three solutions. Now the condition for these three solutions to form a basis is that they have to be linearly independent to one another. In order to show that they are linearly independent, it is enough if we show that the Wronskian of phi 1, phi 2, phi 3 is not equal to 0. So let us find the Wronskian of these solutions. So the Wronskian will be the determinant of phi 1, phi 2, phi 3, phi 1 dash, phi 2 dash, phi 3 dash, phi 1 double dash, phi 2 double dash, phi 3 double dash. And so the determinant value I have found here. And after finding the determinant, we observe that the value of the determinant is 2x cube, which is not equal to 0, because in the question it is given that x is greater than 0. So therefore this is not equal to 0, which implies that the solutions phi 1, phi 2 and phi 3 are linearly independent. So therefore the basis for this given problem is phi 1, phi 2, phi 3, which is x squared, x cube. So we have to conclude the problem like that. Therefore the basis for the solution of the given question is x squared, x cube. Hope you have understood this problem. Thank you.